So consider this given problem statement. So this is the given equation to us, that is log base 10, and in the argument we have 98 plus square root of this particular quantity, that is equal to 0. And if the sum of all possible solutions for this given equation is k, then we need to find the product of this two and the absolute value of k, right? So first of all, I'll write this equation as it is, right? So this is the given equation. I'll write this one as it is. Now let us solve this one, right? So here log base 10 is there, log base 10 argument that is equal to 2. Now I'll convert this into the exponential form. So the argument, I'll write it here as it is, and this can be written as 10 square, that is nothing but 100. So on subtracting 98 on both sides, we get square root of this quantity, that is equal to 100 minus 98, that is nothing but 2. Now on squaring both sides, on squaring both sides under the square root, this term will be as it is, and this will become 4. Now on subtracting 4 both the sides, on subtracting 4 both the sides, here I'll get 36 minus 4, that is 32, and this will be equal to 0. Now this cubic equation, we need to resolve this cubic equation further, right? So this x square, I'll write it as 4x square minus 5x, and this 12x can be written as negative 20x plus 8x. Now on resolving this further, this implies x, I can take as common factor, or x square from this term, and this one can be written as x plus 4. Similarly, negative 5x is common factor, and this can be written as x plus 4. And here we can write plus 8 as the common factor, and here we have x plus 4. So now if you observe, x plus 4 is the common factor. So here we have a linear factor, that is x plus 4 times the quadratic factor, that is x square minus 5x plus 8, that is equal to 0. Now from this, if you can observe here, x is equal to negative 4. And if you check this particular quantity, that is the quadratic factor, so on analyzing this particular part, so from this one we can say, if you can check the discriminant of this, so here the discriminant, if you compute discriminant, that is that is less than 0 in this case, right? And whenever the discriminant of a quadratic expression, so here x square minus 5x, it will be 8 here, right? When it is negative, so in that case we can clearly observe that any real value of x, if you plug it in this particular quadratic expression, this will always be greater than 0. So for this one we can say that for x we cannot have any real solution. So therefore for x, negative 4 is only the acceptable solution. So now the desired answer, now we'll go for the desired answer. So we can say that the expression that is demanded over here, so for k, the only acceptable part is negative 4. So this can be written as 2 times absolute value of negative 4, and that becomes 2 times 4, and that is ultimately 8. So therefore for this problem statement, 8 is the correct answer. So this was the important part, that you cannot solve and get real values for this, because if you check the discriminant, this is negative, and for whichever quadratic expression the discriminant is negative, so therefore that quadratic expression is always greater than 0, and hence any real solution, any real value of x cannot exist, right? So therefore x equal to negative 4 is the acceptable solution for this one. And when we plug it in the solution, so hence the sum itself will be minus 4. So 2 times of absolute value of negative 4, this will be 8, and hence 8 is the answer. So this is the problem statement, and this is the answer. So I hope it is clear.